Hi, this is the Science Chef. In this video, I'll be showing you how to determine your Titre value for the volumetric analysis of the 2024 NECO Chemistry Practical. Alright, based on the instruction that was given, the titration for this year's volumetric analysis is an acid-based titration, and the volume of the acid that you've been asked to use is 3.8 cm cube, while the specific gravity of the acid is 1.8 grams per cm cube. Then the purity of the stock acid is 98%. All these things are important. They're important in determining the concentration of the acid. Now then, the molar mass of the acid, which is 98 grams per mole, and the base that you are using is the mass of the base you are using is 6 grams. You are asked to dissolve 6 grams in 1 dm cube, while the molar mass of the base is 106 grams per mole. This video is specifically for the teachers. This will help the teachers know the concentration of the acid they'll be working with and the concentration of the base they'll be working with, and by so doing they will know, they should be able to determine the expected Titre value for their titration. But remember, it's not a must that you must get that exact Titre value, because whatever you are doing is theoretical value, but it will only serve as a guide to guide you in getting your real value. Alright, so what do we do here? So to calculate the concentration of the acid, in grams per dm cube, we do concentration, to calculate concentration of the acid in moles per dm cube, concentration in moles per dm cube of acid solution, now not the stock acid, right? Calculated as what? The volume of the stock acid that you are asked to dissolve in 1 dm cube is what you are going to use here. That's volume of stock acid. Let me call this SA, stock acid, then times the specific gravity of that acid. Let's call it SG. Now, specific gravity, why do you need specific gravity? Because the acid is a liquid, is a solution, and to calculate the concentration in moles per dm, you need to know the number of moles of the acid that is being dissolved in 1 dm cube, right? So the specific gravity here gives you the mass of the acid present in 1 cm cube of that solution. Are we together? Fine. So that's why we need the specific gravity, which means that specific gravity means that every 1 cm cube of that stock solution contains what? 1.8 grams of the acid, right? Then after that, we multiply this by the purity. Multiply that by the purity. And what is the purity here is what? 98%, right? It tells us that if you take 1 cm cube of that acid, 1 cm cube of that acid is not completely the acid. 98% of that 1 cm cube is the acid, right? And apart from that too, that 1 cm cube, yes, so that 1 cm cube is meant to contain 1.8 grams of the acid, but actually, based on this purity, that 1 cm cube will not fully contain 1.8 grams of that acid. So it will be what? 98% of the 1.8 grams. So that will be the actual mass of the acid in that cm cube, right? Okay, then with this now, we now divide everything. We then divide everything by the molar mass of the acid, right? So what do we do now? The volume of the acid here is what? 3.8. The acid dissolved, or you are asked to dissolve 3.8 cm cube in 1 dm cube. 3.8 cm cube in 1 dm cube. Then times specific gravity is what? 1.8 grams per what? cm cube. Then times the stock, purity of the stock acid, which is 0.98. Right? If you analyze this will cancel out this, right? Divided by what? Divided by 98 grams per what? Per mole. So this grams will cancel out these grams. Are you together? Giving us what? Per dm cube divided by what? Per mole, which is what? Mole per dm cube. So if you evaluate this, you should be getting about 0.0684 mole per dm cube. 0.0684 moles per dm cube. This gives the concentration of the acid you are working with. Are we together? Good. Now the next thing is, let me confirm my calculation. Yes, 0.0684 moles per dm. Concentration must be in what? 3 significant what? Figures. So the next is to calculate the concentration in moles per dm cube of the base solution, which is very straightforward because you have the mass and you have the what? The molar mass of the base, right? So this here you're going to use what? This is the mass you are dissolving in 1 dm cube. So you use concentration in grams per dm cube of base. You know the base I'm talking about, just know the base I'm talking about, divided by the molar mass of the base. Molar mass is in what? Grams per mole. And you see that grams per dm cube divided by grams per mole will give you what? Moles per dm cube. So what is the grams concentration in grams per dm cube here? That is 6 grams, 6.0 grams per dm cube divided by what is the molar mass? That's 106.0 grams per mole. If you evaluate this, that should give you 6 divided by 106. That gives us 0.0566. Gives us 0.0566 moles per dm cube of the base, right? Fine. So the next thing I will do now is to now use our quadratic formula to determine the concentration of, the expected Titre value of the base. Okay, let me refill my ink. Okay, I still have some ink there. Okay, so the acid at the base that we're working with, the acid is a dibasic acid. So I will represent that as what? NaH2X. While the base is a carbonate. Let's say H2Y2CO3, right? So these two would combine to give us Y2SO, Y2X, right, plus H2O plus CO2. Is that equation balanced? Yes, it's balanced, right? So from here, the mole ratio of acid to base that's Na ratio Nb is what? 1:1. And conventionally in our syllabus and practicals, the base is always in the pipette, right? Always. It's not as if it must always be in the pipette, no. But from experience, students are always asked to add the base to the pipette. So it means that the base, the volume of the base here will likely be what? 25 cm cube, right? The volume of the base would likely be 25 cm cube. Well, the volume of the acid would be what you will get from the what? Titre value, right? So I already have our Ca and our Cb. This is our Ca and this is our Cb. So if we now use, so using Ca Va over Cb Vb equals to what? Na over Nb. Right? I hope this equation is balanced. Yes, it is balanced. Okay? Fine. So this gives us what? 1/1, right? So what are we doing for? We're looking for what? Va. So our Va here would be what? Ca times what? Nb, right? All over what? All over, no, sorry. Our Va will be Cb Vb times Na, right? All over Ca times Nb. And what are Na and Nb? 1. So we are going to replace that. That will be Cb Vb times 1 all over Ca times 1, right? So by the time we substitute our, what's our Cb? Our Cb is 0.0566 times our Vb. Our Vb is 25. 25 times 1 all over, what's our Ca? Our Ca is 0.0684 times 1. Now we don't need to convert this to 5 cm cube, since these other ones will what? These other values will cancel, concentrations will cancel out, right? So if you have to calculate that, that will be 0.0566 times 25 equals 1.415. That gives us 1.415 divided by 0.0684. Divided by 0.0684. So that gives us 20 point what? 687, which is approximately what? 687. This is approximately what? 20.69 cm. So that is the expected Titre value for this examination, for the volumetric analysis of the 2024 NECO Chemistry Practical. So I hope you now know what you are expected to work with, right? And with this, you can guide your students on how to carry out their titration. If you're able to obtain any value from this video, kindly hit the like button and subscribe to this channel if this is your first time here, and turn on your notification bell to always stay updated with new uploads. We'll try as much as possible within our busy schedule to see what we can do concerning other aspects of the 2024 NECO Chemistry Practical. So until I come your way next time, I remain the Science Chef. Thank you and God bless.